Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to proceed with the last subtopic from Chapter 4, Heat Balance Application. There are two methods in the analysis of heat exchanger. The first one is the log mean temperature difference method, suitable for the first design task. And in this video, we are going to discuss the second method of analysis called effectiveness E-NTU method. The effectiveness E-NTU method. This method is based on a dimensionless parameter. We call it as heat transfer effectiveness. It is defined as the ratio of the actual heat transfer rate over the maximum possible heat transfer rate. The actual heat transfer rate in heat exchanger is calculated using the formula as illustrated on the screen. Taking into consideration for the cold fluid, heat transfer rate is calculated as mass flow rate of the cold fluid times specific heat capacity of the cold fluid times temperature for the cold fluid out, and also minus the temperature of the cold fluid inlet. On the other hand, for the hot fluid, heat transfer is equal to mass flow rate of the hot fluid times the specific heat capacity times temperature hot in minus temperature hot out. Mass flow rate times the specific heat capacity is equal to capital C, denoted by H for the hot fluid and C for the cold fluid respectively. The maximum temperature difference is temperature of the hot inlet minus temperature of the cold inlet. Therefore, Qmax, or the maximum possible rate heat transfer in a heat exchanger, is calculated as C min times the delta T max, or the T hot in minus T cold in. Let's take a look at example as shown in figure 11.24. We have a counterflow heat exchanger to transfer heat between the cold water and hot oil. The temperature inlet for the cold water is given at 20 degrees Celsius. Mass flow rate is 25 kg per second. And Cp, or the specific heat capacity, is 4.18. For the hot oil that passes through the tube, the temperature inlet is given as 130 degrees Celsius. mass flow rate is 40 kilogram per second, and the specific heat capacity is 2.3. The first step, we have to calculate the capital C for the cooled fluid, which is the mass flow rate times the specific heat capacity. The second step is to calculate the capital C for the hot fluid, which is mass flow rate of the hot fluid times the specific heat capacity of the hot fluid. Next, we have to compare the value of Cc and Ch, which is in this case Ch is smaller than Cc. Therefore, from this scenario, we concluded that Ch is the C minimum. Now we can proceed to calculate the delta T maximum, which is T hot in minus T cold in, and finally compute the value of the Q max as shown. C minimum that we got earlier, which is the Ch 92 kilowatt per Kelvin times delta T max 110, and the value of the maximum heat transfer rate is 10,120 kilowatt. We had calculated the value of the Q max. However, to find the actual rate of heat transfer, we need to find the value of the effectiveness. E, or the effectiveness, depends on the geometry of the heat exchanger and also the flow arrangement. There are few methods that can be used to calculate the value of the effectiveness. Effectiveness has the relationship with the number of transfer unit, or NTU. NTU is calculated as the overall heat transfer coefficient times the surface area divided by C min. The larger the value of the NTU, the larger the surface area of the heat exchanger. Therefore, the size of the heat exchanger will be larger as well. C is the capacity ratio, which is the ratio of the C minimum over C max. The effectiveness of heat exchanger is the function of NTU and the capacity ratio. In order to find the value for the effectiveness, we have to find the value for the NTU and C first, then proceed to calculate or find out the value of effectiveness. What we have in front of us right now is table 16.4. We can use this table to calculate the value of the effectiveness. It is depends on the what type of the heat exchanger that we have. Either is double pipe, shell and tube, or cross flow heat exchanger. We can use table 16.5 to calculate the number of the transfer unit, or NTU. Before deciding which formula that we need to choose to calculate the NTU, we need to identify what types of heat exchanger that we are having. Either it is double pipe, shell and tube, or cross flow heat exchanger. The second method that can be used to calculate the effectiveness or NTU is using this effectiveness heat exchanger plots, or you can find it in your textbook, figure 1127. There are 6 graphs in this figure, whereby the figure A is for the parallel flow, figure B is for the counter flow. On the y-axis is the effectiveness value. On the x-axis is the number of transfer unit, which is NTU. And the blue curve is the ratio of the C min over C max, or the small letter C. Graph C and D is for the tube and shell heat exchanger. For graph C is for the one shell and multiple tube. The tube is multiplied by 2. In figure D is for the two shell and multiple tube passes. The tube is multiplied by 4. Figure E for the cross-flow heat exchanger with both of the fluids are unmixed, and figure F is for the cross-flow as well. However, only one fluid is mixed and another fluid is unmixed. Moving on, we're going to discuss a little bit on the other factors that we need to consider in making the selection for the heat exchanger. The first one, we need to consider about the heat rate transfer. Second point is about the cost. We need to consider the cost for the procurement, maintenance, and also power. Pumping power needs to be considered. Most importantly, about the size and weight, type of the heat exchanger, what are the materials being used for the heat exchanger, so that we have to make sure it is compatible with the fluid that we're going to use. Last but not least is other miscellaneous factors, including either the heat exchanger is prone to leaking. We have to consider in terms of the safety and reliability, and also the quietness. How are you doing so far? Our journey with chapter 4 arrived at the end, but before we conclude this chapter, let's recap what we have learned in this topic. On the earlier of the chapter, we learned about the types of heat exchanger, which there are 4 of them that covered in our subject. And then we learned about the overall heat transfer coefficient. Inside we have the following factors. And then we learned about the analysis of heat exchanger. There are 2 different methods that we can use, which is the first one, the log mean temperature difference method, and the second method using the effectiveness NTU method. Last but not least, we learned about the factors to be considered in the selection of the heat exchangers.